linear inequalities. It's straightforward. There are a couple of twists to it, but not the kind that would make it difficult. Because as long as you know how to graph the equation of a line, you're not going to have any trouble graphing an inequality. Also, there are little tricks on the calculator to help you. Some of them are a little out there, but most of them are pretty useful. So graphing an inequality is dependent on the framework of your equation. So it has to be solved for y in terms of x, right? So y on the left-hand side, everything else on the right-hand side. And so if that's the case, the direction of the inequality is going to dictate for you where the shading is going to happen, all right? So the type of inequality tells us what kind of line we're dealing with. The direction of the inequality tells us what kind of shading we're dealing with. So in the case of the graph of y is less than x plus 4, we're shading below that dotted line at y equals x plus 4, all right? Because a less than symbol or greater than symbol always gets a dotted or a dashed line. All right, so greater than or less than gets dotted line. Greater than or equal or less than or equal gets a solid line. All right. On top of that, greater than or equal means shade above or to the right. Less than or equal means shade below or to the left. All right. So this second pair of statements, that's the confusing stuff, because shading to the right, like, well, wait a minute, looking at this shaded area, did I shade below or did I shade to the right? Because it seems to be a contradiction, right? So if you're looking at any one point along what would be the line, if it were a solid line, all you're doing is shading directly below that line. So that would be a straight line movement in the downward direction. But because there are infinitely many of those points, it creates the illusion of shading. All right, it's not really shading, but it's creating the illusion of that. So if that line were to extend infinitely, you would have shading infinitely in both directions. All right. So to the right, you could look at it and say, yeah, that's to the right, but to the right of what? Right? To the right of a y value is not meaningful. Right? So when I talk about to the left and to the right, what I'm talking about is for vertical cases only. All right, that just blurred it out, so let me just undo that, move it a little, and then it doesn't blur it out for some reason. So for vertical lines only. So the above or below apply for everything else. Shading to the right or to the left only applies for vertical lines, right? So when we're looking at the graph, because again, I don't think it's going to be difficult for you to create the graphs. We've been doing that for a while now. It's just adding this new element to it. Like, for example, you'll see how in each one of these cases, they're all dotted lines because I'm using a greater than or less than symbol in each case. If any one of those were greater than or equal or less than or equal, they would be solid lines. All right. So this one I want to shade above the line. So what I do is I take a point that I know is around that line, and I shade directly up. All right, and I do that for every point. Except I can't draw vertical lines because of, agonizing pain in my arm and back. So this is what it ends up looking like. And so what we end up doing is just shading. All right, but that's the best I can produce. All right, play it safe. If you produce crappy shading like I do, just put an S in it, S for solution, and you're good. All right, shading below, pick a point that's around the line, and then just shade below. You're going straight down below. All right. Now, I recommend you do it at least in a way that's similar to the way I'm doing it here, because as I see people shading, you can come up with some pretty nice shading. It's wonderful. But I've also seen people get too fixated on that during a test and spend like 5 minutes shading their graphs. And then at the end, they wonder why they couldn't finish the test. Nobody cares about the quality of your shading as long as it's clear what you're shading, all right? So it does not have to be picture perfect, all right? This, I'll tell you right now, this shaded region here, the gray shaded area, that's computer generated. I would not have done that myself. Mine would look as crappy as these blue lines. And I recommend that yours look as crappy as mine, all right? Because otherwise you're spending way too much time making math class into art class. All right. So for shading, or the case of shading for x is greater than 3, all we're doing is going to the right, because again, for vertical lines, it's left or right. And you really could just use the arrow to tell you where you're going. All right. So for vertical cases only, that makes sense. It's pointing to the right, so shade to the right. Look at that. You got that done in like less than 3 seconds. And as I'm listening, I can hear that people are still going after a good 15 or 20 seconds. "25 seconds. Okay, finally, I think we stopped. Oh, nope, there it is, 30 seconds. So, yeah, complete and total waste of time.
I love coloring.
All right. So, I'll say it again. I can promise you that if you're spending all your time trying to make the picture perfect shading, you're not going to finish the test. All right? You're not going to have enough time. So, when it comes to graphing a linear inequality, that's where I'm going to let you loose in a second as soon as I show you how to do some of this stuff on the calculator. It's really just a matter of getting it into y equals mx plus b form and then creating the graph using either a dotted or dashed line and then shading appropriately. Tomorrow we're going to talk about linear inequalities as systems. So like we did systems of equations. So we'll do systems of linear inequalities, and so that'll change things up. Right, so the question would be, how do I create some of these graphs on my calculator? And so we start off the same way. I'll take the y equals 5x plus 7. I have to type it in as 5 equals x, y equals 5x plus 7. You don't have a choice in that, right? But we can actually manipulate the shading so that it'll shade the appropriate region for us, all right? So that little slashy thing, some of the newer calculators do a better job with this. You hit enter on the slashy thing, it makes it bold. You hit enter again, and what it does is it'll give you an upward shading. Hit enter again, it gives you a downward shading, the upper and lower triangular. And then what it'll do is it'll kind of trace out the points as they're being plotted. If you hit enter again, that one's very useful. And then this will actually just trace where the points would be plotted, but not actually plot the curve. All right, so the last two aren't really useful, those last two. It'll also create a dotted line, but not with shading, all right? So that's kind of annoying because you'd like to have it do the dotted line and the shading, all right? But it won't do that. But most of the time, people just need their calculator to tell them where should I be shading on paper because the graph itself is not a problem, all right? So the greater than symbol and the less than symbol, greater than or equal, it really doesn't matter. The calculator handles it the same way. Based on our notations here, the greater than or equal, we're talking about shading above. All right, so that would be this case. So that upper triangular region. The lower triangular region is going to be the less than or equal to. All right. So most people at first glance look at this and say, well, that's just something else I have to remember. Why don't I just remember that? And then somebody else always chimes in and says, well, this almost looks like a less than symbol, which is what I have here. And this almost looks like a greater than symbol, which is what I have here. So you're kind of looking at the symbol that you have and saying, all right, well, that's an arrow kind of pointing to the right, which is what I would have if it were a greater than symbol. And that's what I need. So that's the kind of graph I would want. All right, so create my graph, and it'll shade it for us. And you can see that that's the exact same shading that I produced over there. Again, it's not going to do it with dotted lines for us. But if you're concerned, well, I don't know, I can't remember, do I shade above or below for this or that? This corresponds to that as a greater than symbol. It's going to tell you exactly where to shade it, right? So that's good news. There's another way to handle it involving points, but generally I figure this is probably good enough because the other cases involve just doing algebra, right? And it really just amounts to taking a point that's in one of the two regions that could be potentially the shaded area, and then plugging it in to see if you get a true sentence, right? So let's say, for example, in this case, I wanted to test 0, 0. If I plug 0, 0, 0 in for this, what would I get on the right-hand side? 7. Is 0 greater than 7? No, so that would be false. So wherever 0, 0 is, I would not shade that area because that's not a true statement. Right, I would shade the other area because it would be either here or there. If I'm saying it's not here, then it has to be there. All right, but that's mechanical. I feel like this is an easier way to go about it. That's why I'm kind of glossing over that technique. All right, so you have the gift of time, as you often do, almost always do, to work on the assignment, which is completing through page 28 in your package. Right, you got your packets back from yesterday. In some cases, you did not get full credit because you didn't do enough of the packet to get full credit. If that's the case, before you turn in the packet the day of the unit test, you're going to want to go back and make sure that more of those pages are completed. Otherwise, you could expect more of the same grade-wise. All right. So again, pages 24 to 28.